Today we're going to look at section 3.1, solving systems by graphing. And our main goal is to be able to solve a system of linear equations by graphing it either by hand or using the graphing calculator. So what does it mean to solve or to be a solution of a system? Well, if you have a solution, that should be a point or points that are solutions to every equation in the system. So what that means, if you have a bunch of equations, if you find a solution, which is your x comma y, if you substitute that back into each equation, it should make all of them a true statement. If at any point it makes a false statement, it's not a true solution to your entire system. So how many solutions are possible if we are solving the following type of system? So for example, two lines. So if I have two lines, I could draw them like this, where they don't intersect. Okay? I could draw them where they crisscross at some point. And I could draw them where one is right on top of the other. So if we have this would have no solution, because there's no point, x comma y, I can find that satisfies both equations. If I find a point on this line, it obviously is not a point on that line. If I look at this equation, if I look right here, this would have one solution. There's one single point that falls on both lines, therefore making, if I substitute it into their equation, would make both of them true. And this would have an infinite number of solutions, because any single point I pick on one line happens to be a point that's on the other line. These are called parallel lines. There's lots of different names. A lot of people think of them as being perpendicular, okay? But these are actually called oblique lines, oblique. That just means they intersect, oblique lines. It's more specifically called perpendicular if they form right angles, and then these are called coincident lines. Hopefully this one's the most familiar one, parallel. So what if you have a line and an absolute value? Well, here's a line. I could have the line and an absolute value and have these two sides running parallel to each other, where therefore they would have no solution. I could have an absolute value and a line, something like that, where this side and this side are parallel, and they have exactly one solution. I could have an absolute value and a line, where now they have two solutions. And then I could have this, let me switch the color so you can see it, and have a line going down one of the sides. Now this is actually an infinite number of solutions. You might think, well, the lines aren't completely the same, but if I go from here, since this ray extends on forever, if the number keeps going up and up and up, the number of points in common, therefore it's infinite number of solutions. So when you have an absolute value in a line, you get lots of different options. What about two absolute values? Well, I could have an absolute value like this, and let's say an absolute value like this, or where some of the sides are parallel, where I get no solution. Okay, I could have it where, let's do this. An absolute value like this. Okay, and I could do something like this. I could get solutions. I could have it where I have an absolute value like that, and like this. Now this is not an infinite number of solutions, because the only points they have in common are the ones on that little segment. So this would have, technically I guess you could say it's an infinite number, because you can find an infinite number of points even on a small segment. That's for a later discussion, understanding that this still has an infinite number of points on it. But doesn't look the exact same way as a line. Or we could have, for example, an absolute value that looks like this, and say one even larger. And again, this would definitely have an infinite number of solutions. So it's just a couple of different ways. There's lots of ways to draw these, just to show you how many different ways, and if you understand what the graphs look like, you can actually write down how many solutions you actually have. So let's kind of go through a few examples. in this one we have two linear equations, y equals 3x, okay, and this is a slope-intercept form, so let's make it 3x plus 0. So I'm going to go through x, 0, and it's going to have a slope of up 3, right 1, up 3, right 1, and so on. And you definitely, I know when we talked about graphing lines, I said, 2 points do make a line, so you don't have to go all the way across. I like it for accuracy. But when you're actually solving a system by graphing, you do want to make sure you go all the way across your graph to guarantee that the point you get where they intersect is exact. If I look at my second equation, that's in standard form, so I'm going to do my x-intercept and my y-intercept. If I want to find my x-intercept, put 0 in for y, and I'm going to get negative 2. And if I put 0 in for x, I'm going to get a positive 2. And if you do pop up where those two came from, you can go back and watch the section on graphing lines, which is our 2.3 section. So I'm going to go to negative 2, 0 for my x-intercept, and I'm going to go to 0, 2 for my y-intercept. Now, if I want to graph this, and I definitely want more points, I look, I want up 2, right 2, or up 1, right 1. So if I keep doing this, I can tell that these lines are only going to intersect one time. Okay. This line can look like this. And just graphing the points isn't enough. You do need to connect the points. And if you want to connect them after you draw the points to make it a little bit easier to see, you can do that. But if you notice right here is where my graphs intersect. And it's not enough just to do that. You actually have to tell me the point, which would be 1, comma, 3. And if I were to check and substitute 1, 3 into the top equation and into the bottom equation, I would get two true statements. Let's look at the second one. Both these have to be in standard form. But if I look at the first one, it might not be the easiest to graph. You can always change the form if you would like. It's completely up to you. So I'm going to do that here just to show you what that looks like. If I actually solve this for y, I subtract 2x over and then 9. And if I divide by 3, I actually get a nice y-intercept of 3, which I would have got by using, by substituting 0 for x. But if I substitute 0 for y, I'm going to get a 4.5, which might make it a little bit harder to graph. But this way should make it nice and easy. I'm going to go up 3, then down 2, right 3 for my negative slope. I can keep doing that all the way across in both directions to be the most accurate. Now, if I'm giving you a graphing by solutions, I want you to do by hand. The two lines will intersect at integer values, so you're not going to get any decimals. So it will make it a lot easier. Now, if I look at my second equation, this one's really nice and easy. Again, to do by x-intercept and y-intercept. Okay. If I substitute 0 in for y, I'm going to get 2. If I substitute a 0 in for x, I'm going to get negative 2. So I'm going to go to 2, 0, and 0, negative 2. And again, this has a slope of 1. And I can see right away where they're going to intersect. We continue this line on. And again, make sure you connect the points on both of your graphs. And I can see that they both intersect right here, which at that point would be 3, comma. Again, if I substitute it in, I'll get 2 true statements. Let's look at this. Okay, again, standard form. It should be pretty easy to get my x and y intercept. I'm going to substitute 0 in for y to get an x value of 1. I'm going to substitute 0 in for x and get a y value of 3. So 0, 3, and 1, 0. My slope is up 3, left 1, up 3, left 1, or down 3, right 1. My second equation is in point slope form. So let's think about that. My point, opposite of the x, comma, opposite of the y, there's my x1 and y1, and my slope is 3/5, positive 3/5. So I'm going to go to the point negative 3, negative 6. I'm going to go up 1, 2, 3, right, 1, 2, 3, 4, 5. Oh, right away I can see where they intersect, but I want to make sure my line looks nice. I'm going to go up 3, right 5 again, down 3, left 5. Okay, both lines. And again, this should be a nice practice for our 2.3 lesson of actually graphing our linear functions. And I'll look to see what my solution is, and it's going to be a positive 2, negative 3. And let's look at one more example with linear. Okay. My first one, again, is nice and easy, but I actually want to intersect. And the more you practice these things, the further you go, as you can see, kind of with through these. If I substitute 0 in for y, I get 3x equals 12, so x equals 4. If I substitute a 0 in for x, I get 4y equals 12, so y equals 3. I'm going to go to 4, 0, and 0, 3. My slope for this one is up 3, left 4. I'm going to go up 3, left 4, up 3, left 4. Down 3, right 4. Okay. Now, if I look at this, this is x equals 4. Okay. X equals 4 is a vertical line when x equals 4. There's my vertical line. I can see where it intersects the black line that I have drawn here. Right here at this point. So I get the point 4, comma 0. So what happens when we kind of mix it up a little bit? When we have the absolute value and a line. Let's graph the absolute value first. Remember, we look at 3 things. We want to know which way it faces. We want to know the vertex. In this case, it would be negative 5, 7. And we want to know the slope, which would be plus or minus 3 halves. So I'm going to go to negative 5, positive 7. There you go. If you need help with this, it should be section 2.7 is where I spent time graphing absolute value values. So I'm going to go there. I know my slope is going to go down 3, right 2, down 3, left 2 for each side. And one side might extend further than the other depending on where the vertex is on the graph. And then my second equation is linear. Okay, it's point slope. So I know I'm going to get the point negative 3, positive 2, with the slope of negative 1 half. So if I go to negative 3, positive 2, and then I'm going to go down 1, right 2, down 1, right 2. Again, we want to go all the way across. Now, if you notice here, if I didn't go all the way across, I probably would have missed that there are 2 intersection points for this example. That's another reason why I want to be very careful. And let me show you the 2 intersection points. One is here, and one is here. You do have to list both of them, because both are solutions. Doesn't matter the order in which you list them. One is negative 1, 1, which means if I substitute that into the top and the second or bottom equation, it will make a true statement. And negative 7, 4 would also make both statements true. Okay? Both of these are solutions. Let's try another one. Now I have 2 absolute value graphs. So I'm going to graph the first one. This one happens to face up. It has a vertex of positive 2, negative 6, and a slope of plus or minus 1/3. I'm going to go 2, negative 6. I'm going to go up 1, right 3, and then up 1, left 3. I'm going to leave it just as points so I can see the intersection a little bit easier. My second one is going to face down. It's going to have a slope of 2, 5. And, a vertex of 2, 5, and a slope of plus or minus 3 halves. So let's go to 2, 5. Okay. This one faces down, so I'm going to go down 3, right 2. And down 3, left 2. And this one, if you can see, actually does intersect at 2 places. Highlight those for you. One's right here, and the other is there. Again, make sure you list both of them. One of them happens to be negative 4, negative 4. And the other is 8, negative 4. And again, both are solutions. Let's try one more with our absolute value graphs to make sure we feel comfortable with this. Actually, I think 2 more. This one's going to face up. A vertex of 3, negative 1. The slope of plus or minus 2. So we go to 3, negative 1. Here we go. So again, remember this is up 2, right 1, up 2, right 1, and up 2, left 1. And hopefully you'll feel comfortable enough that you can go pretty quick with graphing these because you've done so many of them. Now look at the second one. This one's going to face down. It's going to be at a vertex. Now, if you look at this, this wasn't in the form that we were used to doing in class. We factored out that 8 and got -1, 7 for our vertex. And our slope was plus or minus 1/4 times 8. Okay, it's going to be a 2, or 2 over 1. So I'm going to go to -1, +7. You can see they intersect right away. But it's going to face down, so down to right 1, down to left 1. So if I go down to the left, I'm going to notice that it's not going to intersect. Okay. But if I go to the right, as I keep going down, this is that example I showed you, that little segment where they intersect. So for this one, I wouldn't actually have you list them all out, but I just wanted to show you that it is possible to show you that all of those are solutions. There are an infinite number of points, so I can find any decimal value in between here. So this I would just show you where they are. In our class, we don't actually list those out, but I just wanted to give you an example to show you what that would look like. So how do we use our graphing calculator to kind of help us out? So to use this, all the problems we just did, we could actually have our calculator graph it and show us how to come up with the answer. Now, sometimes you'll have a calculator portion of a quiz, and sometimes you'll have a non-calculator. So depending if I give this to you, maybe you could use it, maybe not, and even if I allowed you to have a graphing calculator, if I asked you to show me using, say, substitution method, or if I asked you for graphing, or asked any of those methods, you would still have to show me it by hand. So we're going to go into our calculator, and kind of go through here. So I'm going to pull up a graphing calculator to kind of help you. What we're going to do is go to the y equals menu quite a bit. We're going to possibly have to adjust our window. We're going to use our calc menu, which is in our second trace, and use the intersection key. So the directions are here for you, so you have them, but we're going to kind of go through these two, and I'll show you how to type them into your calculator. The first thing we need to do is actually get them into a y equals form. So for the first one, I'm going to take this equation and solve for y. So I'm going to get 9y equals 7x plus 11. Y equals 7/9 x plus 11 over 9. If you notice, that's kind of nasty looking, and that's the perfect time to use a calculator. I'm going to the second one to do the same thing. Okay, -5y equals -6x minus 7. Y equals, when I divide two negatives, I get a positive 6/5 x and a positive 7/5. Okay. So here's my graphing calculator. I'm going to make sure I turn it on. So what I'm going to do is go to this y equals button right here. And in my y1, I'm going to type in my first equation. And it honestly doesn't matter which one you pick first. I'm going to do 7 divided by 9. Here's the x right next to the alpha. Plus 11 divided by 9. That's my first equation. I'm going to hit enter and move down. 6 divided by 5. That's how you put in a fraction. X plus 7 divided by 5. Now that I have both equations in, I like to make sure, because who knows when you've used the calculator last or what it looks like. I like this zoom button. Zoom standard or number 6. This gives us a nice 10 by 10 window, and that's what we're used to graphing. And we always try to see, can we see our lines and can we see where they intersect? Sometimes we can't, sometimes we can't. Oh, I can see there's an intersection there, but how can I tell exactly what it is? So what do? I'm going to go to this calculate menu. We get to that yellow calculator after its second trace. And number 5 is my option. You can hit 5 or scroll down to it. And what it's going to do, now my cursor happened to go right to it, yours might not. But what it's going to ask you is 3 questions. One, it's going to say, was this what you typed into Y1? And the answer is yes, so you can just hit enter. Is that what I wanted in my Y2? Yes. The reason I ask you that is because you could have multiple equations in, and they want to make sure they're picking the right 2 that you want to find intersecting. Since we always just put 2 in at a time, you always hit enter for both of those questions. And now they said guess where it is. What they mean by that is if your cursor is over here, they would like you to move your cursor to about where it is. Now, technically, you don't have to. You'll still get the answer. But depending on what your window looks like, if your cursor is close to it, you will get a more accurate answer. So I'm going to hit enter one last time. And now they give me an answer. They told me x equals negative 0.42, and it keeps going on, and y equals 0.89. Now, those are nasty decimals. And unless I ask for a decimal answer, I always want the exact answer. So how do you change these to the exact answer? Well, your calculator stores this in x and stores this in y. So if I go back quick and go to my home screen, if I hit x, I hit enter, there's that point. So I can hit math fraction and get an answer. How do I get y? Well, if I look here, here's my alpha y. I hit enter, that was my decimal. Just to make sure, I hit math fraction, and that's what I get. So I get the point negative 8/19, comma 17/19. Negative 8/19, comma 17/19. And there's my solution. So how do I do this with absolute value? Now these are already solved for y for me, which is really nice. So what I'm going to do is go back into my y equals, and I'm just going to hit clear, get rid of these. So I'm going to just start typing this in. I have 3. Now I need to put in the absolute value symbols, but there are no lines. So what we do is hit the math button. If I go over 1 to number, it says ABS, and it stands for absolute value. So I'm going to do the absolute value, and then hit 2x minus 5. Now I have to be sure to close it, because it's going to do the absolute value of what's ever inside the parentheses, minus 9. And enter, we'll do the same thing, negative. Whenever you start with a negative, make sure you use the negative, not the minus sign. 3 divided by 7. I'm going to go back to math, over to number, and hit enter for absolute value, and hit x plus 1. Make sure I close parentheses, plus 4. So both of those typed in. Again, my zoom should stay here, but I'm going to show you again, zoom 6. I'm going to see if I can see both my absolute values, my b's. And they graph both of them. Now, it's not great to use this to draw. If I asked you, say in a test, draw this absolute value graph, because it's hard to get accurate, so that's why we do it by hand, but this saves us a lot of time. So we hit second trace, number 5. Now, if you notice it hits more than once, and this is why it's really important, that when they ask you to guess where 1 is, I move my cursor close to it. I'm going to hit enter, and I'm going to get some crazy decimals. So again, now my calculator has re-saved x and y. So I'm going to quit. There's my new x. I'm going to change it to a fraction. And alpha 1 gives me y. Just make sure that was it. And I'm going to change it to a fraction. So I'm going to get 17/39 and 44/13. But I need to remember that there were 2 answers. So I'm going to go back to my graph. I'm going to do it again, second trace, go down to number 5. But now if you notice, I can go up and down and jump between my 2 equations. So I'm going to go up to that graph. I'm going to actually just move my cursor close to where the other intersection point is. Okay. I'm going to hit enter for the first curve, enter for the second curve, hit enter again. And now I get these 2 points. So 4.28 and 1.73. Quit again. And change x. Okay. Just to show you, change that to a fraction. And I'm going to go to y. And again, you could do this all in one step and change it to a fraction without looking at it. So now I'm going to get 193/45 and 26/15. So let's write that down so we have it. So now I'm going to get 193. The reason we don't want to use the decimal is because if we were to substitute in a rounded decimal into either of these equations, we would not get a true statement. That's why it's so important that we get it. So these are our 2 answers for this.